Hello everyone, welcome to the class. Today, let's talk about in assembly how we represent the loops, branches, this kind of logic, important logic unit of your C languages. How we actually use assembly, write the assembly to support this. This is an example for if-else statement. So let's take a look of the original if-else statements code here and what's the logic we can convert it to assembly in the second one. Then we look at the details of assembly. So for the first one, you can see this actually compare this function called abstract absolute value difference. We try to compare x and y. If x larger than y, we do x minus y. Otherwise, we do y minus x. We always get the absolute like difference of the x and y, and we return the result. So very simple like a concept, like a function. So the the logic to convert this code to assembly is not too hard to understand. We can use a different way to represent this code by using goto. Goto is a keyword in C. We we don't recommend you use go to this keyword because it will make your code hard to debug. But we can use a go to represent the code because it can help you to understand the assembly. So what it actually do? It actually do is if you have two branches. If x larger than y, you go one line, otherwise you go another way. So we can kind of have a uh, different way to represent this. We set up the label. So there's a label here. If x less than or equal to uh, the y, which means if x less than or equal to y, we want to execute this one, right? So we say go to else means we just ignore everything here. We just jump to this line. So everything here will get ignored. Then we can compute the y minus x, which is equal to this case, right? Case 2. This is case 2. Then we finish. We just return a value. This is the idea. Okay, so if x is not less equal to y, which means if x is actually larger than y, what happened? It will compute the case 1 here. This is case 1, and you can see it is case 1 here. After you compute case 1, because you don't want to compute a case 2, so we use another go to here, try to go to the exit, which means we jump. This part we got is got ignored. And we jump to exit, we return to a result. So this is kind of the same idea how to represent the if else statement. We still have two branches. One is if it's true, otherwise it is false. We use a label this concept to represent this. So we have two different go to, one here, one here. These go to the else case, which means the case 2. This means case 1, and it's go to finish. So if you understand this part, then let's take a look over assembly. For assembly part, let's do some like a review again. In future examples, I will skip this step. For first part, we do a some setup. The setup, we move EBP. We try to save all the EBP. So there's all the EBP save to here. Then of course we need to update ESP because we do the push. So ESP point to the top. Then we move ESP to EBP. So which means we make the EBP point to the same place of your ESP, which means this one. So they point to the same one. So this is setup. For this setup, after the setup, we still have some other like setup stuff, which means we want to create some space to store the data. So what we actually do is we do the sub ESP, which means we create this kind of like 16 byte area. We make a ESP, we sub it, right? So we make ESP point to here to create 16 byte space. In the 16 byte space, this is just for preparation. We try to save this data, this 16 byte locate like a position to support some data store, say some other data store like a result. We want to support this local variable result, so we give some space. Okay, so then what we actually do here, EAX equal to the A shift EBP. So since the EBP is here, plus A will be this one, plus 12 will be this one. So we got the actual address X to EAX, address X to EX, and we put the address Y to E. Oh no, we don't put the address Y because we do a comparison. We just compare the address X and address Y. So right now we compare this is address Y, this is address X. We compare this result. If after we compare the result, the registers will kind of like save the result in some way. So we can use the result to do a comparison here. Jump if less or equal to. So LE jump, J means jump, L means less than, E means equal to. Same thing here. If X less equal to Y, if the data in address Y compared to the data actually this is X, this is not address X, okay? Because we load the X here. So this is the X, not address X. So we save the X here because we use the address. We move the data in this address to AX. We compare X and address Y plus 12, which means we got the Y here. We compare X and Y. If the answer shows the Y larger or equal to X, Y larger or equal to X, then we try to jump to the label 2. Where's the label 2? Here. So we jump to label 2 here. So this is actually the second case, okay? This is second case. Then otherwise we do the first case. So this part is the first case. So in this case, you have a first case here and second case here. And here we also do this because if it's less than or equal to, you jump to the second case. Otherwise, you just continue to the next case until you hit this line. It will jump to the end. So it will skip the second case here. So the same logic as what we wrote in the GoTo versions, right? So let's take a look of what happens here. If this is the first case, if this is the first case, we know the X is actually larger than Y. If we know X is larger than Y, what we actually do is, first of all, of course, we move some data. We move the data X and Y. We move the Y data to EX. We move the data for X into EDX. So then what we do is we also move EDX to ECX here. So we move X to here. Then we do a subtraction. We do the EX subtract ECX, and we store the data into the ECX, right? So we actually do is we do the subtraction. We do the subtraction of EX and ECX. So we try to compute it. We try to compute it and get the result. And then because the result will store into the ECX1, so we need to move the ECX back to EX. Why? Because of return value. So if you remember in other video, we mentioned that EX, we usually use EX to store the value, right? So here, what we actually do is we do a computation. Let's take a look of here. We move EDX to ECX, then we subtract EX to ECX. So we subtract EX to ECX, which means we do X minus Y because ECX is X, EX is Y. So we subtract X minus Y and we store the data to ECX. So ECX got updated to X minus Y. Then we move X minus Y to EX. Why? Because we want to store the return value. So we update this part, EX, this part, we update it. We update it to X minus Y. Then we move this return value to BBP minus 4. where? Here. So we put x minus y to this place because EBP minus 4 is will go down, right? Then we jump to the last one. So we do the finalize. This is how we actually do for the first branches case. The second branches case is very, very similar, except here you put the wrong, if you look at the order will be different. The first one, EX got the Y, EDX got the X. Here, EX got the X, EDX got the Y. Everything else is the same. You do everything else is the same here. The only difference is when you load the data, you load in a different direction. So no matter no matter how you actually do in the last 4 assembly code, you will still get the same result because you already changed the order of this place. You make the bigger one minus the smallest one, right? Then after that, go to the end. This is how your branches actually do. So the key of branches is what? Is a label. If you can be expert of a label, you can understand, you can read the assembly code here, okay? Let's see another example. This example is do while. Still, in assembly, using a loops, not just branches. For loops, we also use a goto or label to support the loops. Imagine that loops is something like a lot of if statement. If this happen, you do this. Otherwise, you finish a loop. So it means a lot of if statement here. If this will happen, do this. Check the if statement again. Do this. Check the if statement again. False. Finish. So if you understand the logic, let's see how we use a goto to represent the do while, this kind of stuff. The do while code here is very simple. You have a result, 0. Every time you just plus I, and you have an initial value for I is 10. Every time you just minus the I from 10 to 9, 9 to 8 until what? Until this value. This value, if I is larger than 0, is some positive number, then means true. You will continue to do this. If I equal to 0, then you finish. So here you compare I equal to 0 or not. So this is a very basic idea. So what we can do for this one using a goto loop. First of all, we have a same initialization. This is the same initialization. The difference is you have a label here. If you do a result, blah, blah, blah. If this happen, if this is still true, you go back and you just continue to do a result plus I and I minus minus. Then after that, you do a return when this equal to 0. Then you finish. Otherwise, you just keep go to the loop. So we use the same logic to write the assembly. For assembly, first of all, we still do some like setup stuff. We still give a space for local variable and so on. And what we actually do here is, first of all, we try to support the initialized value. So we have a 10, number 10, which is your I value. We have a 0, which is your result. So we initialize these values. And so these two lines match to these two lines, okay? Then we have a label. Label is a key of the branches and these loops. So we have a label loops. This label, what it actually do is, first of all, it try to do the computation. So these two lines is actually matched to, let me use the yellow. This two line is actually matched to this line. So we do result plus I. So we move the data to the registers because you cannot do the computation to do the operations on both memory part. You need to move one data from memory to registers, then you can work on a register with the memory. So these two lines match your result, and this line match to this line match to the subtraction. Okay, then what we actually do here, the comparison is here. We comparison the data, the I equal 0. So right now, EBP minus 4 is I. We compare EBP equal to 0. If it's equal to 0, we finish. So compare, if that is 0, we don't do anything. So what can give us the way to check this? J and E. J means if it's not equal, jump not equal. If the comparison result is not equal, we jump. Otherwise, we continue. So which means if I not equal to 0, what is actually do? Jump back to L2. Then you just continue to do anything again. Then if you compare I still not equal to 0, you just go back, check it again. If the comparison result equals 0, then you won't jump. Then you will continue to do anything left in this function. This is the logic of the do while. And if you understand the do while, we can apply to a while and loop in a very easy way. In this case, this is a while loop. The while loop try to do initialize value and try to do the comparison first, then do the computation result, and so on. So again here, everything here is the same, just some like create some space for local variable, do some like start up. And this part is actually try to initialize. So this is the initialize part. And what is actually do is very similar to previous one. The previous one, we do some computation that we decide we want to jump or not. Here we don't, because while loop need to do the comparison the first. We want to go comparison first, then we do the computation. The do while we do computation and we comparison. So what it actually do is just to go to the comparison part. So you can see the comparison part is here. This is the comparison part. So the while loop is actually equal to here. And the jump to this comparison part first. If they are not equal, then you need to go to computation, right? If they are not equal, you need to go to the computation, which means this is the green part. This green part is here. This is the idea of how to change it is to from do while to while. So for do while, you compute it, then you compare. Here, we just directly jump it. If you can look at this comment, there's no condition. It's just called jump. There's no jump not equal, jump equal. There's no. It's just go to jump to the comparison part. Then if the comparison part not equal to 0, which means it's not finished, you want to continue, then it will jump back to do the computation. This is the logic of this while loop. And the while loop and for loop, you can always convert these two to each others. So this is the idea for loop. Again, we still have an initialized value here. We also have another initialization here. We change the result to 0, I to 10. And I larger than 0, or we can say I not equal to 0. We can do something like this, I minus minus. Then otherwise, so everything here is update. This is the updating. So very similar to a while loop version, this computation, we still have initialization, we still have a comparison, we have another part is the computation. So again, here we have the same startup, the setup. And we have a same initialization here. So this initialization set up the IN result. Then we have the jump to here to do the comparison. So we have a comparison here. Then if the comparison not in this case, we use is greater. If it's greater, then we jump it. And in previous example is if it's not equal, right? So very similar, but here if it's greater, then we jump to the computation part. Okay, we jump to the computation part, which is here. So this is computation. Okay, so computation is here, and initialization is here, and another part, the green part, is here. So very similar. Actually, if you look at the code for while loop and the code for the for loop, the only difference is just in here. We change JNE to JG. JNE means not equal, JG means greater. This is the only difference. So why we can always change the for loop to a while loop? Because they are equally. In assembly, they are the same. Which one has a better performance? The same, right? So from the assembly, you can also learn something for your other languages. You will understand or do more analysis about what's the performance of this code in more like a higher level, like programming languages, how they actually do. So is that the difference between the loop or while loop, the for loop or while loop? The answer is no, not difference. Okay. So hope you got this part. You got this part, and you understand how you actually use a label. The label is very important, a key, kind of key. To understand assembly, I would suggest you to understand the label stuff like a little bit more. Then it will help you to read the code, the loops, or either the loops or conditions. You will get the more sense when you understand, after you understand how to use a label, how to read the label in the assembly codes. Okay. So this is for today. Today we talk about in assembly how we write the branches, how we write the eval statement, how we write some loops like your do while loop, for loop, these kind of different loops. Actually, in assembly we use a label, this concept, and this is very useful skill to understand when you read the code, assembly code, or when you want to write the assembly code. I hope you enjoy today's videos, and I hope you can, at this moment, you are ready to review, you are ready to like read assembly codes. Okay, so I hope you enjoy today's videos. See you next time. Assembly is really cool.